So a bit of revision first. When I update a table and I set salary equals, add 10% to everyone's salary, and I go, oh, I forgot a where clause. I need to do a rollback. The obvious question is, how does the database do that? And it's pretty simple, and most of us are familiar with the concept that we have to remember the information that was there before we changed it in order to put it back in place. Let's look at a rough schematic of how this would actually occur. When I do an update, the first thing I'm going to ask the database to do is give me a slot in the undo header block, which simply says, I'm going to allow you to actually start recording some undo such that if you need to roll back, you'll be able to. Here's my employee table. Let's assume the first set of rows sits on block 2754, and there's my first 5 rows. So in that block, I'll record what we call the undo block address. This is where I'm going to record the information in order to roll back this transaction should I need to. The undo header will now link me to an undo block. It'll say, yep, you're about to change row number 1 in block 2754. If I need to undo the change you're about to do, I need to set the salary back to $1,000. So that's what the information that goes inside the undo. Now that that's been recorded, I'm allowed to actually make the change to the block and say, yep, add 10% to Smith, and he changes from 1,000 to 1,100, as you can see in the left. And then we do the same thing for row number 2. The salary would need to go back to 900, and then I can change Jones on the left to be 990. If my undo block gets full of information to actually undo that transaction, I can simply link in additional undo blocks. And that's when we can see our undo table space is growing to record things like, in this case, block 3, salary 1,500, and block 4, and so forth. So you can see at the final state, I've made the changes on the left to my block, and I've got sort of a trail of how to undo that information, sort of a list of instructions as to what to do if I choose to do a rollback. So when I do a rollback, I simply look at my block 2754. It says start undo block address 5.2, which is that block down the bottom there. And I roll back the information in reverse order. So start with row number 4, take the salary, set it back to 2,000. Then move along the pointers and undo that information, go back to salary 1,500. And as I'm undoing this information, I'm also undoing the undo, if that makes sense. That undo now becomes freed up for other use. Row number 2 says go back to 900, and I keep on going. And eventually, I've cleared out my undo, and my block is back to how it was before. So that's a vast simplification of how undo works, but you get the idea. Store a set of instructions as to how to undo a transaction and apply them if someone asks you to do a rollback. Way back in Oracle 4, someone said, you know, this transaction rollback stuff's pretty cool, but we could probably use this for queries. And that's where the great thing about Oracle, that read consistency, comes in. The ability to actually run a query at a fix at a given point in time. And this is really cool. This is sort of how it works. You can see on the left, I've got session 1 at 9 a.m. He starts a query. And even though at 9:03, session 2 comes along and changes the employee table, it doesn't matter. Session 1 is going to see that data as it was at 9 o'clock. What that means is, though, at say 9:05, when this, let's say the employee table is very big, at 9:05, when session 1 finally stumbles across block 3217, which is the block that was changed by session 2 at the right there, he's going to see that version of the block which has been altered at 9:03. And he needs that block as it was at 9 a.m. If I've got a table block that was changed at 9:03 and I need to get it as it was at 9 o'clock, what do I have to do? I have to undo the transactions that were applied. I have to do a rollback of that particular transaction. And the time equals the SCN when it comes to Oracle. That's the system change number. So let's walk through that query example in sort of block speak now to see what's going on. Block 3217 had the SCN of 456003. And in fact, the only thing to remember here is the last 3 digits of our SCN. That's the rest I left unchanged. Session 2 came along and said, yep, I need to update the employee table. And so what do? We move along the SCN number because we've moved along that block in terms of its time. So that update says, yep, take block 3217, change XYZ to ABC because that's what the update statement says, give it a new SCN number, 4567234. As a result, that transaction must obviously record undo because I might want to roll back that transaction. So the undo information says block 3217, if I want to undo the SCN from 234 back down to 003, I would change ABC back to XYZ. That's what goes in the undo information. So session 1 comes along and says, look, my query is I've been running since for about 5 or 6 minutes now. So I've just encountered block 3217. I need it at SCN 192. I look in the buffer cache or even on disk and I say, well, I've got a problem here because block 3217 is now at SCN 234. Well, that's way too new for me. If I use that data, I'm returning corrupt results. So what I do is I take a copy of that block because someone else might be using that block as it currently stands. And then because I know that if that block was moved along in terms of time, it's SCN moved, there must have been a transaction to do it. I can go look up the undo for the transaction that session 2 did and apply that to that copy of the block. So I can take the undo in the yellow there and say, let's apply that. And I'll take block 3217 back to SCN 003, which means the employee name was XYZ. Now 003 is less than the initial request there of SCN 192 that session 1 needed. So now my block is correctly up to date in terms of I've taken it backwards in time and I can use it for session 1's query. So that's effectively how read consistency works. It's on the fly applying undo from other people's transactions. At which point you're going, well, thanks a lot, but how about my question? Why am I getting lots and lots of IO on a small table? Well, let's go to a new share and I'll run a little demo. So I'll start with a little small table called D. It's only got it's only got one column and it's got 10 rows. And I can query them 1 through 10. Very small table. Now let's run a couple of queries on that table. So the way I'm going to do it is I'm going to open a couple of cursors. So I've got ref cursor R1 and ref cursor R2. Now let's open those cursors. You can see there at the start I've done open R1 for select star from T and open R2 for select star from T. At this point in time, I'm going to run a query that shows me how many consistent gets have I run so far in this session. And I've run 650. Now that's actually to do things like drop the table, create the table, etc. So how many consistent gets is it to actually do a select star from T? Well, we can do that by actually going and fetching from ref cursor R1. So I did print of R1, it just scrolled off. I got my 10 rows back and I went from 650 consistent gets to 654 consistent gets. So I did 4 consistent IOs, 4 logical IOs to print out ref cursor 1, which was just select star from T. Ref cursor 2 is select star from T as well. Now I run host SQL plus and I'm running a secret script. And there's no smoke and mirrors here. I'll show you what the script is shortly. But I've run a secret script that does something. My table is still the same size. There's my consistent get, 654 in this particular session. Now I do print ref cursor number 2, which also is just a simple select star from T. Now look at this query. I did 100,652 consistent gets against a 1 block 10 row table. Why? Well, the clue's there in the second line, which is 9,994 of those, 99,994 of those were actually applying of undo records. What was I doing in that secret SQL Plus session? You can see it there at the bottom of the screen. I did 50,000 transactions against the table called T. Because I'd opened up the cursor on R2, the ref cursor R2, before I did those transactions, when I came to fetch from R2, I had to undo 50,000 transactions worth of data in order to produce the result as it was when the cursor was opened. It's that schematic we just saw in SQL Plus. That's why you can often see huge amounts of I/O against what appears to be small queries or small tables. What's going on is a lot of undo information is being required. So when you start seeing these things where, for example, queries that used to run fast suddenly run slow against the same data and the same plans, what it might be is a lot of DML going on in your application that's causing your applications to have to do a lot of undo work. And that statistic we saw before, data blocks consistent undo records applied, is where you want to be looking for to actually see what we're up to.